In this module, you will learn to prove theorems related to probability. Let's prove a theorem on the probability of event A or B, where A and B are events of a sample space. This theorem states that if A and B are any two events of sample space S, then the probability of event A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Let's observe the figure. From the figure, we notice that B minus A union A intersection B is equal to B. Similarly, B minus A intersection A intersection B is equal to phi, which is a null set. It implies that events B minus A and A intersection B are mutually exclusive. Now, P of B is equal to P of B minus A union A intersection B. Since events B minus A and A intersection B are mutually exclusive, P of B is equal to P of B minus A plus P of A intersection B. This implies P of B minus A is equal to P of B minus P of A intersection B. Let this be equation 1. Again, from the figure we have A union B minus A is equal to A union B. A intersection B minus A is equal to phi. This implies events A and B minus A are mutually exclusive. Now, P of A union B minus A is equal to P of A union B. Since events A and B minus A are mutually exclusive, P of A union B is equal to P of A plus P of B minus A. By using equation 1, we get P of A union B is equal to P of A plus P of B minus P of A intersection B. If A and B are two mutually exclusive events in sample space S, then A intersection B is equal to phi, and therefore P of A union B is equal to P of A plus P of B. If A and B are any two events in sample space S, then P of B minus A is equal to P of B minus P of A intersection B, and P of A minus B is equal to P of A minus P of A intersection B. Let's look at an example. Find the probability of getting a prime number or an odd number when a cubical die is rolled. Let A be the event of the occurrence of a prime number. It will consist of the numbers 2, 3, and 5. Let B be the event of the occurrence of an odd number. It will consist of the numbers 1, 3, and 5. Thus, A intersection B is the event of the occurrence of an odd prime number and consists of 3 and 5. Now, the probability of A is equal to 1/2. The probability of B is equal to 1/2. The probability of A intersection B is equal to 1/3. Now, A union B is the event of the occurrence of a prime number or an odd number, which is 1, 2, 3, and 5. The total number of possible outcomes is 6. We know that P of A union B is equal to P of A plus P of B minus P of A intersection B. On substituting the values of P of A, P of B and P of A intersection B, we get 2/3. Hence, the required probability is 2/3. If A, B and C are any three events in a sample space, then P of A union B union C is equal to P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of C intersection A plus P of A intersection B intersection C. To prove this, let's consider P of A union B union C. This is equal to P of A union B union C. By using the theorem on the probability of an OR operation of two events, we get these steps. Since A intersection B intersection A intersection C is equal to A intersection B intersection C, we get P of A union B union C is equal to P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of C intersection A plus P of A intersection B intersection C. Hence the theorem is proved. Now, let's prove a theorem. If A is an event of a sample space, then A' is the complement of event A, and P of not A is equal to 1 minus P of A. We know that events A and A' are mutually exclusive and exhaustive. This implies A union A' is equal to S and A intersection A' is equal to phi. Now, P of A union A' is equal to P of S. By using the axiomatic approach to probability, we get P of A plus P of A' is equal to 1. This implies P of not A is equal to 1 minus P of A. Hence, the theorem is proved. Let's look at an example. If the probability of event A is 3 divided by 8, then the probability of event A' is equal to 1 minus the probability of A, which is equal to 5 divided by 8.